Greetings of the day. Welcome to the course on Operations Research Technique. Students, we are now in Unit 2 and we are on the verge of completing Unit 2. Earlier in Unit 2, we have seen assignment models, and right now we are solving the problems pertaining to transportation model. If you recall in last lectures, we have seen various methods for finding initial solution to a transportation problem, and then we have started with optimizing the initial solution, and we have adopted modified distribution method. So I will start my today's lecture from the point where we have ended our last lecture. If you recall our last lecture, sorry, in that particular lecture what we did is we have calculated initial feasible solution for a minimization type of transportation problem, and we have then evaluated values of ui and vj. Now what I am marking is with a red circle is nothing but the quantity allocated. So if you recall again, by using this particular formula at unoccupied cell and at occupied cell, we had that discussion. So at occupied cell we have logic cost is equal to ui plus vj, and by this logic we have calculated these various costs as this is u1, this is u2, this is u3, and this was v1, v2, v3 and v4. Again, in last lecture we have started with assumption let v4 equal to 0, and then we have applied this particular formula for calculating the values of remaining u1, u2, u3 and v1, v2, v3, v4 we have assumed 0. I have explained that you can take any u1, u2, u3 or v1, v2, v3, v4, any value equal to 0 in the beginning. But I have explained with reason that select that particular row or column u or v which is having maximum allocation as 0, and since this particular column is having maximum 3 allocations, we have equated this v4 equal to 0, and we have evaluated this particular we have evaluated values of ui and vj by this cost for occupied cell. Now important, after that what we have to do is we have to find, very important step now, what we have to find is opportunity cost. We have to find opportunity cost, and that too for opportunity cost I have already explained, it is to be calculated for unoccupied cell. We have to calculate opportunity cost for unoccupied cell, and if you recall, we have said in last lecture that we will be denoting this opportunity cost by variable d, small d. ij I will comprise for rows, j's for column. So now here this is to be evaluated for unoccupied cell. So, and the formula which we are using is how this dij will be calculated. I will first write generalized formula Dij is equal to of course Dij for unoccupied cell is equal to cost at unoccupied cell minus ui, corresponding ui plus vj. So now you will come to know how we will be calculating opportunity cost by using this particular relation. So first what we will do is we will write all these opportunity cost like different D's. So here this is the cell which is unoccupied cell. So I can write D, it is actually D1, 2, D1 means S1, 2. Other is, first we will write pertaining to D all, D1, 3 is second. Third is D, now second row D2, 1. Third will be D2, 2. Next will be D3, 1. Next will be D3, 1. And last will be D3, 3. This is very important. We'll now evaluate the values and we'll decide whether the current solution which we got is optimal or not. Now, sir, is it necessary to write D12 like that? What will happen, sir, if I write D S1 D2? That will do. Here, if suppose one write D S1 D3, so I have omitted S and D later, and I have considered in a mathematical order that we know. First we consider rows followed by columns, so we are following that. Now important calculation, and what the test says, if all these values are 0 or positive, this solution is optimal. But if any single value of this 1, 2, 3, 4, 5, 6, any single value is negative, this solution which is under test is not optimal. Further improvement is possible. That we will check whether it is like that or solution is optimal. So first what we will do, D12. Now what it says, Dij is equal to cost. So what is the cost as D12? D12 cost is 30. So it is 30 minus, it's very important, 30 minus, now see here the values are, V2 is equal to minus 12 and V3 is equal to minus 20. You have to be very careful regarding the sign. So I have written cost 30. Now for the same cell, you have to check corresponding UI and corresponding Vj. So it is UI, that is U1 is 10. Now actually it is plus 10 plus, but it is minus. Actually it is plus, and Vj is minus. So minus 12. So being first problem, I am writing in detail. So actually this plus minus will become minus. So one has to write 30 minus 10 minus 12. So minus 2. So minus 2 minus, this will be minus 2. Minus of minus is plus. So this will end with 32. First value of D12 is 32. So this is in detail I have written. I have to take minus sign. So I have taken minus 12 as it is. Then there is plus sign in formula. Plus minus is minus. 10 minus 12 is minus 2, minus minus plus, 30 plus 2 becomes 32. That is the case. Now D13. D13 cost is 50 minus, same logic, 10 plus 10 plus, it is minus 20. So plus minus is minus. So what we will write? Suppose minus 20 and equal to. So it will be minus 10, minus 10 minus plus 10. So if you add it, it will be nothing but 50 plus 10, it will be 60. Again I am reminding you are to be very careful while putting these negative values. If you commit mistake in this, your signs for this opportunity cost will wrong, and we have studied that it is the only sign convention of DIJs which determine whether solution is optimal or not. Now for D21, it is 20 is the cost minus 20 is the cost, D21 70 is the cost, corresponding U2 is 60, and for this 70 it is V1 9. So U plus V is 60 plus 9, it is 69. So ultimately 70 minus 69, it has to be 1. It is 1. Similarly, now for D22 cost is 30 minus, for this 30 U2 is 60 plus, U2 is 60 plus, for this 30 it is minus 2 minus 12 minus 12. So ultimately it will be 60 minus 12, so it will be 58, and 30 minus 58, it will yield minus 18. Minus 18. Next we will calculate D31. D31 is 40 minus 40 minus U3 is 20 plus it is 9. 9 means 29. So 29, 40 minus 29 is positive 11. And last is D33 70 minus D33 70 minus, this is 20 plus minus 20. So ultimately this 20 plus minus 20 is 0, 70 minus 0, minus minus plus 0, ultimately it remains 70. So students, this is complete lengthy step in modified distribution method for deciding whether your initial solution or solution in between is optimal or not. And if you recall the steps, there we have written that if any single value for minimization type of objective function, if it is negative, solution is not optimal. So here you can see that amongst these values 32, 61, minus 18, 11 and 70, this particular value minus 18 for D22 is negative, and therefore students, this solution is not optimal. Improvement is possible. Got it? Would it have been positive value? then this could have been optimal solution. Now, since at least we are getting one negative value, solution is not optimal. There are chances you may get more than one negative also. In that case also, your solution is not optimal. Now, what we have to do? We have to move further ahead, move towards next better solution. So we have to find closed loop of previous allocations with this minus value opportunity cost. How to do that I will explain now. Now, how to draw closed loop? This is a very important step. For drawing closed loop, first I will draw. This is one example of closed loop. This is other example of closed loop. This is third example of closed loop. Closed loop means at corner of loop you should have allocations. At corner of loop you should have allocation, and loop should be joined only by drawing vertical and horizontal lines with the loop. Loop should be drawn by drawing only vertical and horizontal lines, no cross lines like this. It is not permitted. Only by drawing vertical, horizontal and vertical lines. But which will be the starting point for drawing loop? So starting point for drawing loop is decided on the basis of your opportunity cost. You have to select that particular cell as a starting point where you are having most negative value. Here we are having only at one cell, so there is no question of tie, or there is no question of any decision. We have to start loop from D to 2. We have to start loop from D. Yes, it is 1, 2, 3, 4. 1, 2, 3, D to 2. Now, suppose in particular problem, in any other problem, you get two values like minus 18 and other value. By chance, if it comes out to be minus 20, what to select? So remember one thing: most negative opportunity cost cell. Again, I will reiterate. The starting point for the loop will be that cell which has largest negative opportunity cost. Here we are having only one, minus 18. Suppose the case is like minus 18 and minus 9. Suppose in minus 18 and 9, minus 9, which is largest negative? Yes, minus 18 is largest negative. But now suppose the scene is you are getting one value as minus 18 and other value minus 25. So which will be largest negative, students? Yes, minus 25. So that particular cell we will select as the cell to begin with starting of loop. Again, loop will be like this. These are some cases, examples, where on these corners I have mentioned there has to be presence of allocations. Also, it is mandatory that loop must have allocations at corner. Allocations may be present in between also. That will not harm your problem flow. But mandatorily, allocations must be there at corners. That is true. So now, we will identify first this cell D22. So, D22 is this cell. So what you have to do is tick mark right that cell, which is having least negative opportunity cost. And then draw series of horizontal and vertical lines. Very important step. Draw series of horizontal and vertical lines starting from this loop with other allocations, so that at corner of loop you are getting allocations. So see here, now if I start from this path, I can go up to this, but there is no further journey from this. From this it is up to this. I can go up to this, from this to this, but I cannot return back to 30. So this path is meaningless for me, because through this path I will only reach up to cell 1 1. I cannot go back to cell 2 2. You have to remember one thing: from the point where you start your journey, you have to come back to the same by ending that particular loop. So this particular route is not worth. Second we will try. So second is, one can say, sir, okay, I will take this, I will go here, I will go here, I will go here. I won't go here because we have already checked that at this point there is hurdle. So what I will do, I will go from this location to this location and back to this. Yes, this is good, correct. A loop is formed. So how that is done? See here, that where you have marked tick, this is starting point. So what we will be doing is, I am drawing this loop. I am drawing this loop. I have already mentioned that there can be a location in between. There can be a location in between. I have already mentioned. So there is a location in between. Now what is important? A very important step. Wherever you have tick mark, put there plus sign. Very important. And alternately, suppose one put tick mark over here and plus sign here. So alternately you have to put plus, minus, again plus, minus, plus. Don't put any sign for the allocation which is not at the corner. If allocation is lying between ends, there is no need to put any mark, any sign for this allocation. If you carry out this particular thing, so plus minus, plus minus, plus minus, plus minus, plus minus and plus. So it will end like this. So if I am marking this right side plus, this will be minus. Very, very important point. This will be plus and this will be minus. See that I have not given any sign to this allocation 17. Now next step is identify the allocated value. Very important step. Identify the allocated value from the cells where you are having minus sign. So for this particular loop, we are having minus sign in this cell and minus sign in this cell. And for this, what values are there for allocation? This is 12 and this is 8. Important step. From the cell with minus sign, identify allocation, previous allocation values, and in that select minimum allocation value. Now here we are having one allocation value with minus sign as 12, other as 8. So out of this 12 and 8, which is minimum? I am not saying largest negative, I am not saying from that point, which is minimum from minus sign cell. These are the cells with minus sign. So two values of allocation, one is 8, other is 12. So amongst 8 and 12, the minimum value is 8. This is first part. And now once you did this, what you have to do? You have to add this minimum to the cell where you have tick mark. Earlier there was no value over here. It is 0. So now if I add here with plus sign this minimum value, so here the allocation value will become 8. Here the sign is minus, so 8 minus 8 will become 0. In short, this allocation will be shifted to upper cell. In short, this allocation will be shifted to other cell. In previous case, prior to this, there was no allocation, means 0. 0 plus, because of plus sign, 0 plus this minimum value. Here in next iteration, it will be 8. Here 8 minus 8, it will be 0. Next, here we are having, we are having allocations as 2, and here allocation, this is not 12, this is 2. 2 and 8. This is 2 and 8. So amongst 2 and 8, minimum is 2. Minimum is 2. This is 2. Minimum is 2. So what we'll do? We'll add 2 at this place. So 0 plus 2 will become 2. We will subtract this 2 from this minus sign cell. So 8 minus 2 will give me 6. We will add this minimum to 2 plus sign cell. So 10 plus 2 will become 12, and here we will subtract this 2 from 2. 2 minus 2 will be 0. So here in next iteration what we will get? 0 means no value. Here it will be 12. Here it will be no change because it is not lying at the end. 7 will remain 7. This will remain, this will change now. Since tick mark is there, means earlier there was no allocation, highest opportunity cost. So 0 value was there. 0 plus 2 will be 2 here, and here it will be 8 minus 2, 6. So what we'll get in next iteration, that I will tell you. In next iteration, here I will write for your understanding, for better understanding, and then we'll switch over to the slide. So in next case, what I will get? Here I will get 8 minus 2, 6. Here I will get 2. Here it will be 7 as it is. Here it will be no value. Here it will be 10 plus 2, 12. So important thing is that what we are doing in improvised solution is we are shifting the place of allocation, but total supply and demand doesn't change. You can cross check here. 5 plus 2, 7. 2 plus 7, 9. 6 plus 12, 18. Vertical. 2 plus 6, 8. 5, 7, and 2 plus 2, 2 plus this 2 has gone. 2 plus, this is 2. 2 plus 12, 14. So students, you have to keep in mind that whenever you improve upon your solution, only position of allocation changes, total supply and demand doesn't change. Got it? What we have done? That earlier solution was not optimal. Therefore, we got next improved solution, which I have written with this green chalk now. And now our target is to check whether this is optimal or not by doing all this business, all this. So your transportation algorithm will now go in do loop. It will repeat and it will terminate at a point. There will be one point of termination. It will terminate at a point where your all these values, allocation, these cost opportunity values are positive. At that point, this problem will end. So now, we did this particular exercise. In next case, what we'll get? We'll get new allocation as I have mentioned, and then we have to again cross check it by doing this business of assuming U0, U1, U2, U3 or V1, V2, V3, 0 as the case may be, and then moving further. So that we'll see now. So but remember, this particular calculation is repeated till you get all opportunity cost either 0 or positive. 0 will do, but no negative. No negative. Got it? Let's move ahead. Now, this is our next problem, next feasible solution after we got initial solution by VAM. So here what will happen? Sorry. Again I will write these values as it is. This is 19 cost values I am writing. 19, 30, 50, 10, 7030, then 40, 60, 40, 60, then 48, 70, 20, 70, 20, and new values of allocations that we'll write precisely. It was 5, then it was 2, followed by 7, then 2, then 6, then 12, and demand and supply were as it is, that we know. It is 5, it is 8, 7, 14, here 7, 9, 7 plus 2, 9, 18. So we know this was, we have written in previous case, it was 34 by 34. So students, now this is the second improved solution. Why I am saying second? Because the first initial solution we have calculated with the help of VAM 779. The answer was rupees 779. We have checked optimality for that solution by modified distribution method, and we got one opportunity cost value negative. As I mentioned, the problem has entered in a loop. Again we have to repeat the same process. Again we have to repeat the same process till what? You get opportunity cost either 0 or positive. Now here in last case, if you recall my again dialogues, which V1, V2, V3 to take 0. So in that case, if you recall, we have taken V4 0 because there were maximum allocations in that fourth column. Now here every row and column is having, this row is having 2 allocation, this row is having 2, this row is having 2, this column is 1, 2, 1, 2. So there is at no row or column you are having more than 2 allocation. So what we will do is we will proceed with U1 equal to 0. And when we proceed U1 equal to 0, now we will find the values which we have calculated in a lengthy discussion in previous slides. If you are not remembering, you can go back to the presentation, to the lecture, and find the steps discuss. So how we have calculated these values? So at occupied cell cost was equal to ui plus vj. So you have to start from this. I have assumed u1 equal to 0. So to get this is allocation, then this is the cost. So students, this 10 cost at allocated cell is result of u and v. So which is this value of v4, which will bring this sum 0. So naturally 0 plus 10 will bring this cost 10. So 10 plus 0 is 10. That is the logic. Now follow the same route. First complete this route of u1. So now you are having u1 0. Go to this allocation. This allocation is having value 19. So which is the value of v1 by which you get u1 plus v1 equal to 19. So definitely it is nothing but 19. So value of v1 is 19. That is simple calculation. If you commit mistake over here, entire problem will go wrong. So right now we have calculated these values. So I am having this value of v1. I have this value of v420 for v410. For this cost the value is 20. So corresponding value of u3 as explained earlier, which value of u3 plus 10 is 20. So 10 plus 10 will give you 20. That is the logic. Now you have v3, no sorry, this is u3 20. So u3, this is allocated cell. So which is the value of v2, that 10 plus which value will give you 8. So 10 plus minus 2 will give you value 8. This is how you have to calculate. Now once you are having this value, it is the task to find the value of v3. So how? See here, can you directly find now? It will take time. Before that, find this value of u2. So for finding value of u2, this is allocation. Cost 30 is minus 2 plus which value? So naturally, if it is 32 minus 2 gives 30. Now I am having the value of 32 over here, 40 over here. So which value of v3 plus 32 is 40? So it is 8. Students, again I am reminding, in my last slide I have in detail explained how with formula how these values are to be evaluated. If you commit a simple mistake in calculating any of ui and vj's value, your entire problem will go wrong. Now once you do this, your task is to find what? Your task is to point, next is, anybody? Can you guess? Yes, you have to find opportunity cost. Opportunity cost. For what? For unoccupied cell. Unoccupied cells are those cells where you don't have allocations. See, I am repeatedly, many times I am repeating the same word intentionally, so that that word must enter into your mind and it should clarify that yes, sir is repeatedly saying this word means this is related to this aspect, that opportunity cost is always to be connected with unoccupied cell. So here, for finding this unoccupied cell, the opportunity cost which we are expressing in the form of D's, and for that you know Dij is equal to cost minus ui plus vj. Cost minus ui plus vj. So now if that is the case, so you have to identify like D12 is first, then D13, then D21, then D24, then D31 and D33. So these are the cells for which you have to find opportunity cost. Now how to proceed? Quick, we'll go D12 30 minus, for this 30 it is 0 plus 8. Okay, I'll write here complete. 30 minus 0 plus 8. 0 plus 8 is 8, so it is 22. It is 22. Then for second D13 it is 50 minus again 0 and 8. 0 plus 8. This 0 plus this is 8. No, it has to be, it is wrong in first. It is not 8 is this value. This is wrong. So 30 minus, you have to focus on this value. 30 minus u is 0 plus, for this 30 it is minus 2. So minus 2. So ultimately plus 2 minus, so it will become 32. Then 50 minus 0. 50 minus 0 plus, this is 8. So here it is 42. Next is D21. D21 is 70 minus this 32 and plus 19. So 32, 42, 52, 51, it is 19 positive. Now D24, you are getting or not? D24 is 60 minus 32 plus 10, 60, 32 plus V4 is 10 plus 10, so 42, 30 plus 10, 42, 60 minus 42 is 18. Got it? Now this is very important. I am putting this by star mark. D31, it's 40 minus, for 40 it is 10 and for 40 it is 10 plus 19. 10 plus 19. 10 plus 19 is 29. So ultimately it is 11. And D33 is 70. This value is 70 minus, for the 70 it is 10 plus corresponding is 18. So value is 70 minus 18. 70 minus 18. So that is 52. So again, very detailed, I have shown you how to calculate opportunity cost. Now test. Important test. What is the test? What is the test? All these values must be 0 or positive. So see, 32 is positive, 42 is positive, 19 is positive, 18 is positive, this 11 is positive, and 52 is also positive. So there is no negative value of opportunity cost. Hence, this second improved solution is optimal. Very important. Now transportation algorithm terminates. No further improvement is possible. So we'll find what is the minimum cost for this allocation. So final answer is this, what I have written with blue color, this final allocation. Why I am saying this is final allocation? Because for this allocation I have checked opportunity cost and there is no single negative opportunity cost, and therefore transportation algorithm terminates. Now, so students, with that allocation which we have seen in last slide, this minimum total cost comes out to be rupees 743. If you recall, the first solution which we have optimized, which we got by VAM method, the minimum cost was rupees 779, and we have interpreted by calculating that value of opportunity cost that this is not optimal, and we have improvised. Minimum is further, minimum cost is not possible for this particular problem. Hence, this is the way how to interpret the test of optimality of the revised solution. Once again is the same as discussed earlier. I have discussed in earlier slide the values of shown in the table, and each is positive. Since the values which I have shown on previous slide are positive, this second improved solution is optimal with this minimum transportation cost. So here this problem ends. There may be chance that again, if you are getting any opportunity cost negative, then you have to add one more step, two more steps as demanded by the problem. So this is how in detail transportation problem by modified distribution method is optimized. Now we'll see special cases. I will just go through how to tackle with the special cases. Now this special case pertains to unbalanced supply and demand. Unbalanced supply and demand. So this is the matrix given. So if you sum up this requirement, demand, and this from these particular points the pickup location these values. So one is giving you supply and another is giving demand. As we have seen that in transportation matrix, we have to check supply and demand. If demand is more, we have to add dummy supply. If supply is more, we have to add dummy demand. So what is done? This problem is converted into appropriate transportation matrix here. You can see this matrix, and now here the demand was less by, in original matrix, the demand was less by 20. So the case was, original supply was, in previous slide the supply was 235, supply was 235, and demand was 215. So there is gap of 20. There is gap of 20. So I have explained this concept in my earlier lecture also. So you have to add dummy demand. So this dummy demand is added, and to begin with you have to put, since this is dummy, you have to put this cost value 0. Now once this is done, now this has become balance transportation problem. So total demand, supply 235, total demand 235, and then normal apply first to VAM, then MODI for optimization. MODI for optimization, the same method as we have applied for earlier case. Now if you solve this problem, so ultimately final solution is like this, and we got some allocation in this demand. We got some allocation in this demand, that is 20. So since it is dummy demand, so cost is 0, 0 multiplied 20, null effect is 0. So it will not affect your final cost, which is this for this particular problem, once you solve it by initially by VAM and optimize by modified distribution method. And if you are having the problem of this nature, these are specialized cases, therefore I am discussing. If you are having the problem like this, maximization of transportation problem, then what you have to do? You have to only convert that problem into minimization type of problem, and you have to solve it for further clarification. So what we did today is we have optimized our entire problem by modified distribution method with objective function of minimization. We have seen how to convert unbalanced problem into balanced transportation problem by adding dummy row or dummy column. And right now, in last slide, if you are having problem pertaining to maximization type of problem, what is the first step is subtract all element of that maximization matrix from highest element of the same matrix. That will give you relative minimization type of matrix. Solve it by all related steps, that is initial solution by VAM, then optimize by MODI. But while interpreting final answer, interpret that final answer from your original table of maximization values. So students, today we have finished unit number 2, that is transportation and assignment model, and from next lecture we'll start unit number 3, which is dynamic programming. Till then, solve these problems. Practice these problems.